Chapter 15 in class exercise 1, problem 15.11. Linear impulse and momentum problem. This is the equation, this is the principle of linear impulse and momentum, that initial momentum plus sum of all the impulses equal to final momentum. During the operation, the jackhammer strikes the concrete surface with a force which is indicated in the graph. So this is the force with which the hammer strikes on the ground. To achieve this, the 2 kilogram spike S, which is here, is fired into the surface at 90 meters per second. So it goes down with 90 meters per second. Determine the speed of the spike just after rebounding. So we need to calculate for this problem speed of the spike after it hits the ground. So it rebounds and then it moves upward. So we need to calculate T2, speed of the spike after rebound. Now, since this equation is actually a vector equation, but the entire motion of the spike here as well as the impulse is along vertical direction only, or along only one direction, we will use the scalar version of this equation. So we don't use ijk unit vector for the direction, but we just write the magnitudes only because everything is in one dimension only. And we assume that any motion or force going up is positive for us. So we define our xyz coordinate system. X is horizontal, there is no motion in x, but y is vertical, and vertical going up is positive. So let's write down the linear version of this, the scalar version of this equation, that mv1 plus sigma f dt integral 0 to t equals mv2. Now v1 and going up is positive. So v1 for this problem is velocity of the spike, initial velocity of the spike, which is minus 90. Negative sign because we have assumed that going up is positive. v2 is what we need to determine. How about the impulse itself? So that force is given as a function of time. So from that we can find out the impulse. Now integration of a graph is nothing but the area under the graph. So we need to find the area of two triangles, this small triangle and this other big triangle, and that gives us the total impulse. So let's draw the impulse momentum diagram that for the spike. So this is the initial momentum of spike plus impulse force which is applied from the ground. As a result of that, pile changes its direction of this motion and moves in the upward direction. So this is final momentum of the spike. So remember, always draw the impulse momentum diagram. Initial momentum plus impulse equal to final momentum. Now, before we apply this equation, we need to calculate the value of the impulse force, and that's area of this graph. So let's calculate this area. So integral sigma f dt is equal to area under the ft graph. So this is in milliseconds, and that's in kilonewton. Our final answer we need is in Newton and second. So to convert kilonewton to Newton, we need to multiply with 10 to the power 3. But to convert millisecond to second, we need to multiply with 10 to the power minus 3. So that will cancel out. So area of the first triangle is 1/2 times base, which is this 0.1 times height, which is 1500. And as I mentioned, we need to multiply actually this 0.1 with 10 to the minus 3 and 1500 with 10 to the 3. So they will cancel out. Plus area of the big triangle is 1/2 times base, which is this. It's not 0.4, but it's actually 0.4 minus 0.1. So it's 0.3. Multiplied by 1500. Again, this is multiplied with 10 to the minus 3, and this is 10 to the power 3. So this area is total area is 300 Newton second, and that's our impulse. Okay, and now we can substitute everything into this equation. That's our impulse momentum equation. So once again, I'm writing it here, mv1 plus sigma f dt. Sorry, sigma should be here. Sigma f dt equals mv2. So mass of this spike is given as 2 kilogram. This is minus 90. This we have calculated as 300. This is again 2 kilogram. And V2 is positive because V2 is in the upward direction. So from this we can calculate V2 as 60 meters per second. And it's going up. So that's how we apply the principle of linear impulse and momentum and calculated the final velocity of the spike. So the steps are: define the coordinate system, draw impulse momentum diagram, calculate the linear impulse using the area under the graph of force and time, and then substitute that in the linear impulse and momentum equation and calculate the final velocity. Thank you.